Okay, so yesterday we started looking at inequalities, where instead of having an equal sign, we have an inequality sign, either a greater than sign, a less than sign, greater than or equal to, or less than or equal to. Okay, Kyler? Okay, so now we're going to look at solving inequalities. So we're going to find all the values, an expression for all the values that make the inequality true. And on Thursday, we're going to have a quiz on this stuff. So tomorrow will be our last lesson on inequalities. Thursday will be our quiz. And then next week, we'll have some review for your test on this chapter, covering equalities and inequalities. So again, our next quiz is Thursday. So solving a linear equality is very similar to solving a linear equation. You must isolate the variable, just like you did in solving equations. However, there's one minor difference. Let's take a look at what happens when we either divide or multiply both sides of an inequality by a negative number. So it says the following statements are all true. Multiply both sides of each inequality by -3 and see what happens. So this first statement says that 5 is greater than 2, which is true, obviously. If you multiply both sides by -3, let's see what happens. So we multiply -3 on the left and -3 on the right. -3 times 5 is -15. On the right, 2 times -3 is -6. Originally, the number on the left, 5, was greater than the number on the right. But now, the opposite has happened. Now it's the number on the right that's the larger number. -6 is greater than -15. So let's see what happens for the next one. Again, that's a true statement. 8 is greater than 6. If we multiply both sides by -3, let's see if the number on the left is still larger than the number on the right. So we'll have -3 times 8, which is -24. 6 times -3 is -18. So again, the inequality will reverse here. Now the number on the right is the bigger one. -18 is greater than -24. So in both cases so far, the inequality reversed when we multiply by a negative value. Well, let's see if that pattern continues. The next set of numbers, the number on the right, 4, is greater than the number on the left. If we multiply both sides by -3, -3 times 3 is -9. On the right, 4 times -3 is -12. Now the number on the left is larger than the number on the right. -9 is greater than -12. So again, the inequality reversed. Checking this last example one more time, see if the same thing happens. Originally, the number on the right, 6, is greater than the number on the left. But when you multiply both sides by -3, you get -6 on the left, -18 on the right. Again, the number on the left is now larger than the number on the right. So the inequality reversed. And that will always happen. If you have an inequality and you multiply both sides by a negative value, the inequality will reverse. So that's one difference between equations and inequations. When we did equations before, we didn't have to worry about multiplying or dividing both sides by a negative number. It changed nothing. But now, if it's an inequality, it does change things. It reverses the inequality. So let's see what happens when we divide each side by a negative number. Let's see if the same thing happens. This first expression, the number on the left, 8, is larger than the number on the right, 6. If we divide both sides by -2, 8 divided by -2 is -4. 6 divided by -2 is -3. Now the number on the right is larger. -3 is greater than -4. So the inequality reverses. Let's see what happens for the next example. Again, the number on the left is larger than the number on the right. 12 is greater than 4. If we divide both sides by negative 2, 12 divided by negative 2 is negative 6. 4 divided by negative 2 is negative 2. The number on the right is larger than the number on the left. The inequality reversed when we divided both sides by a negative value. The next one, the number on the right, 9, is greater than the number on the left, 3. Now it says to divide both sides by negative 2, and we can do that. We'll just get decimals. But instead of negative 2, in this case, let's divide by negative 3, because both those numbers are divisible by negative 3. 3 divided by negative 3 is negative 1. 9 divided by negative 3 is negative 3. The number on the left is greater than the number on the right. The inequality reversed. And the last one, if we divide both sides by negative, let's do negative 6 in this case, because both numbers are divisible by negative 6. 6 divided by negative 6 is negative 1. 18 divided by negative 6 is negative 3. Negative 1 is greater than negative 3. Again, the inequality reversed. So in each case, what we notice is that the inequality reversed. Meaning it changed its direction. And so what is our conclusion? Our conclusion is that when an inequality is either multiplied or divided by a negative value, the inequality will reverse. When an inequality is multiplied or divided by a negative value, the inequality reverses. So that's what happens when we multiply or divide by a negative value. Otherwise, everything's exactly the same when we're solving inequalities comparing to solving equalities.
Solve for c and graph the solution. We have negative 5c is less than or equal to 15. So negative 5c is less than or equal to 15. I just rewrote it a little bit bigger. So if we want to solve for c, we just want to isolate this c right over here on maybe on the left-hand side. We have it's right now being multiplied by negative 5. So the best way to just have a c on the left-hand side is we can multiply both sides of this inequality by the inverse of negative 5, or by negative 1/5. And let me just, so we want to multiply negative 1/5 times negative 5c, and we also want to multiply 15 times negative 1/5. I'm just multiplying both sides of the inequality by the inverse of negative 5, because when this will cancel out with the negative 5 and leave me just with c. Now I didn't draw the inequality here, because we have to remember, if we multiply or divide both sides of an inequality by a negative number, you have to flip the inequality. And we are doing that. We are multiplying both sides by negative 1/5, which is the equivalent of dividing both sides by negative 5. So we need to turn this from a less than or equal to a greater than or equal. And now we can proceed solving for c. So negative 1/5 times negative 5 is 1. So the left-hand side is just going to be c is greater than or equal to 15 times negative 1/5. That's the same thing as 15 divided by negative 5. And so that is negative 3. So our solution is c is greater than or equal to negative 3. And let's graph it. So that is my number line. Let's say that is 0, negative 1, negative 2, negative 3, and then I could go above 1, 2. And so c is greater than or equal to negative 3. So it can be equal to negative 3, so I'll fill that in right over there. Let me do it in a different color. So I'll fill it in right over there. And then it's greater than as well. So it's all of these values I am filling in green. And you can verify that it works in the original inequality. Pick something that should work. Well, 0 should work. 0 is one of the numbers that we filled in. Negative 5 times 0 is 0, which is less than or equal to 15. It's less than 15. Now let's try a number that's outside of it, and I haven't drawn it here. I could continue with the number line in this direction. You would have a negative 4 here. Negative 4 should not be included, and let's verify that negative 4 doesn't work. Negative 4 times negative 5 is positive 20, and positive 20 is not less than 15. So it's good that we did not include negative 4. So this is our solution, and this is it. This is that solution graphed. I want to do that in that other green color. Here you go. That's what it looks like.
Okay. So we're going to solve these inequalities and graph the solution on the number lines, and then it says use a test value to check our answer. So again, we do exactly the same thing as we did with the equations, except if you end up multiplying or dividing by a negative value, we have to remember to reverse the inequality. So we want to get x by itself. And the first step then would be to get rid of the minus 5 by adding 5 to both sides. And so on the left, negative 5 plus 5 cancels. We're left with 2x on the left, equaling on the right, 7 plus 5 is positive 12. So we added 5 to both sides. We did not multiply or divide by a negative value. So the inequality will not reverse. And it won't reverse for our next step either, because our last step, whoops, I put equals there. Let me fix that. It's greater than or equal to. My last step is to divide both sides by 2, positive 2. So again, the inequality will not reverse. It stays greater than or equal to. On the left, 2 divided by 2 cancel. On the right, 12 divided by 2 is 6. So there's our solution. X has to be greater than or equal to positive 6. So we'll put 6 on our number line. That's where we're starting, and it's included because it says x is greater than or equal to 6, which means we have a closed dot on 6. And now, to graph our solution, we'll have an arrow that goes to the right because x is greater than or equal to positive 6. So using a test value to check, if I use 7, which is greater than or equal to 6, and I plug it in here, 2 times 7 is 14. Take away 5 is 9. 9 is greater than or equal to 7. So that test value does work. If I choose a value less than 6, let's say 5, 2 times 5 is 10. Take away 5 is 5. 5 is not greater than or equal to 7. So this shows us that our solution is correct. Okay. Question B. First thing I would do probably is I would add the 14 to both sides. So again, we're adding a positive value to both sides. That doesn't change the inequality at all. That only happens if you multiply or divide by a negative. So negative 14 plus 4 is negative positive 10, and the inequality doesn't reverse. What we have left on the right side is just the 5n. And now we'll divide both sides by positive 5, so the inequality does not reverse because we're not dealing with a negative. 10 divided by 5 is 2, and again, the inequality did not reverse. And you always read these from the variable. N is less than 2. 2 is greater than n, but n is less than 2. So we're going to start at positive 2 on the number line with an open dot because the 2 is not included. It's not less than or equal to 2, it's just less than 2. So in this case, our arrow will go off to the left. All numbers less than 2 should work. One such number would be 0. And when n is 0, 5 times 0 is 0. Take away 14 is negative 14. Negative 14 on the right is smaller than negative 4 on the left, so it checks. If we chose a number greater than 2, let's say 3, 5 times 3 is 15. Take away 14 is 1. 1 on the right is not less than negative 4. It's greater than negative 4. So that just shows us that a number like 0 works, whereas a number like 3 doesn't. Okay? So it just verifies that our solution is correct. So same thing with example 2. We need to get the m by itself. The first thing I would do here is subtract 4 from both sides. So on the left side, the 4 minus 4 cancels. I'm left with negative 3m on the left, greater than or equal to. Negative 5 take away 4 is negative 9. And again, if you're still having problems with integers, use your calculator. Negative 5 take away 4 is negative 9. And now we need to divide both sides by negative 3. So because we're dividing by a negative value, the inequality will reverse. I'll have m, instead of being greater than or equal to, it'll now be less than or equal to. On the right side, negative 9 divided by 3 is negative 3. So in this case, we divided by a negative value, so the inequality reversed. So to graph it on a number line, we'll put negative 3 on there close to the middle. M is less than or equal to negative 3, so it means you're going to have a closed dot, because not only is it less than, but always equal to, also equal to. And we're going to have an arrow going to the left, because it's less than or equal to. So any number less than or equal to negative 3 should work, like negative 4. When m is negative 4, negative 3 times negative 4 is positive 12. Plus 4 is positive 16. That is greater than or equal to negative 5. If we chose a number, let's say like negative 2, which is not part of our solution set, negative 3 times negative 2 is positive 6, plus 4 is 10. So there's something wrong here. Negative 3. Oh, because I'm dividing by negative. Yeah, you're right. So this is why it's so important to check. So this becomes positive 3, not negative 3. And so again, this becomes positive 3, not negative 3. So again, this shows the importance of doing that check. So now a number less than positive 3 would be positive 2. Negative 3 times 2 is negative 6, plus 4 is negative 4, and that is greater than or equal to negative 5. But if I use a number like positive 4, I'd get negative 12 plus 4, which is negative 8. And negative 8 is not greater than or equal to negative 5. So now we checked it, and our answer works. Question B, I would start by subtracting the 2 from both sides. So again, subtracting a value never changes the inequality, only if you multiply or divide, which is not what's happening here. So that leaves us with x on 4 less than 1. 3 take away 2 is 1. And now I will multiply both sides by positive 4. The opposite of dividing by 4 is multiplying by 4. So 4 times 4 cancels, or 4 divided by 4, I should say, cancels. And we have x is less than 4. So if we show that on our number line, we'll put 4 in the middle, open dot, because x is less than, not equal to, and we're going to have a line that goes off to the left, again, because it's less than. So to check that, if we use a number less than 4, like, let's use 0, just because I'm dividing by 4. 0 divided by 4 is 0, plus 2 is 2, that is less than 3. If I use a number like 3, I might use a calculator to help here. When x is 3, 3 divided by 4 is 0.75, plus 2 gives you 2.75, which is still less than 3, so it works. But a number greater than 4, like 5, 5 divided by 4 is 1.25, plus 2 is 3.25. That's not less than 3, that's greater than 3. So that shows us that 3 works, but 5 doesn't. So our answer that x is less than 4 appears to be correct. Question C. I would probably start by bringing the 3x over to the right by subtracting 3x from both sides. So they're going to cancel on the left. Note we still have a negative 3 on the left, less than or equal to. 6x take away 3x is 3x plus 12. Now I will subtract the 12 from both sides to get the 3x by itself. So on the right side, the 12's cancel. On the left, negative 3 take away 12 is negative 15, and that's less than or equal to 3x is all that's left on the right. And finally, we'll divide both sides by 3, a positive 3, so the inequality does not reverse. On the left, negative 15 divided by 3 is negative 5, and again, the inequality does not reverse. On the right, the 3's cancel, so you're just left with x. And if we read from the variable, it's x is greater than or equal to negative 5. So we'll put negative 5 in the middle. That's our starting point, and that point is included because x can be greater or equal to negative 5. Because it's greater than or equal to, the line goes off to the right. There's our solution set. To check it, a number greater than or equal to negative 5 might be negative 4. So I'm going to actually check this by writing it out just because there's x's on both sides, so it's just going to be a little bit easier. So again, our solution is x must be greater than or equal to negative 5, so we can use negative 4. 3 times negative 4 is negative 12. Take away 3 is negative 15. On the right side, 6 times negative 4 plus 12. 6 times negative 4 is negative 24 plus 12, which is negative 12. The number on the right is greater than or equal to the number on the left, so it checks. Okay, it checks. Question D, the first thing I would do there is multiply out the brackets. 4a take away 20 greater than 2a plus 28. I'll take that here. Thank you. You have your equalities and inequalities package. What page are we on? 16? 16, 1, 6? Yeah. Okay, thank you. So I first multiplied out the brackets. Now, I'm going to subtract 2a from both sides. 4a take away 2a is 2a minus 20 is greater than 28. I'll add 20 to both sides. So on the left, the minus 20 plus 20 cancels. I'll have positive 2a greater than 48. And finally, we'll divide both sides by 2. The 2's cancel, and it's a positive 2, so the inequality does not reverse. I'll have a is greater than 24. On the right, 48 divided by 2 is 24. So on our number line, we'll have 24 in the middle. That circle or that dot is not colored in because a is only greater than 24, not equal to. And because it's greater than, the line goes off to the right. So number greater than 24 could be 25. So if I'm checking this, when a is 25, 25 take away 5 is 20, and 4 times 20 is 80. On the right, 25 plus 14 is 39, and 2 times 39 is 78. The number on the left is greater than the number on the right, so it checks. It checks. Question E. I would probably start this by collecting the numbers together. I would add 3 to both sides. Collect the numbers together. I still have a negative 1/2 on the left, but the 3's cancel. And again, I added 3, so that's never going to change the inequality when you add to both sides. On the right, 2 plus 3 is 5 minus 1/3 x. Now, I'm going to get rid of the denominator. I have a denominator of 2 on the left, a denominator of 3 on the right. I'm going to get rid of those by multiplying both sides, multiply everything by the common denominator, which would be 6. That includes the 5. All 3 terms need to be multiplied by 6. Let me just write this a little more clearly. So on the right, 2 plus 3 is 5. That needs to be multiplied by the 6 as well. And the reason this works is because on the left, 6 divided by the 2 is 3. So it's going to be 3 times negative 1, which is negative 3x, less than. 5 times 6 is 30. And that last term, 6 divided by 3 is 2, times the negative 1 is negative 2x. So this is how we multiply everything by 6, because we get rid of the denominators. Again, the 6 divided by the 2 is 3, times negative 1x is negative 3x. The 5 is also multiplied by the 6 to give us 30. And the 6 divided by this 3 is 2, times negative 1 is negative 2x. So now what I would probably do is add the 2x to both sides, but that's still going to give us a negative on the left, and that's fine. We can deal with that. Negative 3x plus 2x is negative 1x, and that has to be less than 30. On the right, the 2x's cancel. But now I'm going to divide both sides by negative 1. To get rid of the negative symbol in front of the x, I'll divide both sides by negative 1. And so now the inequality is going to reverse. I'll have positive x on the left Instead of being less than, it's now going to be greater than 30 divided by negative 1 on the right is negative 30. So there's our solution set. If we put negative 3 in the middle, that dot will be open because it's not included. X is only greater than negative 30, not equal to. And because it's greater than, the arrow goes off to the right. So if we're going to check this, start with the original expression. And I need to use a number that's greater than negative 30. And maybe just to make things a little bit easier, why don't we choose a number greater than negative 30 that we can divide both by 2 and 3 and not get a decimal. So negative 24 is one such number. Negative a half times negative 24, take away 3, 2 minus 1/3 times negative 24. So negative a half times negative 24 would be positive 12. Take away 3 is 9. Negative a third times negative 24, that's the same thing as negative 24 divided by negative 3, which will be positive 8. And 2 plus 8 is 10. The number on the left is smaller than the number on the right, which it's supposed to be. So it checks. It checks. Question F. First thing I would do there is multiply out the brackets. I'll get 4m take away 8 less than or equal to 2m plus 2, right? Only the m plus 1's in brackets, so that's the only part that's multiplied by the 2. And then you have the minus 6 on the end. So finish that off, and then we'll check it, see what you get. So on the right side, I would probably combine the 2 minus 6. 2 minus 6 is minus 4. I would subtract the 2m's from both sides. On the right, they cancel. On the left, 4m take away 2m is 2m. I still have the minus 8, less than or equal to negative 4. And my next step would be to add 8 to both sides. But that doesn't change the inequality. We're not multiplying or dividing by a negative value. We're simply adding 8 to both sides. So on the left, negative 8 plus 8 cancels. So if I write it up here, I'll have 2m left on the left, less than or equal to negative 4 plus 8 is positive 4. And then if we divide both sides by positive 2, that does not change the inequality because we're dividing by a positive. So the 2's cancel, you'll have m is less than or equal to positive 2. So if we put positive 2 in the middle, that dot will be colored in because it's less than or equal to, meaning our arrow will go off to the left. So any number less than or equal to positive 2 should work. And that includes positive 2. Maybe I'll do my check just below here. Always start with the original expression. And I'm going to let m equal 2. So on the left, inside the brackets, 2 minus 2 is 0. 4 times 0 is 0. On the right, when m equals 2, inside the bracket, 2 plus 1 is 3. 2 times 3 is 6. And 6 minus 6 is also 0. So we get the same thing on both sides, and that's fine because it says that m has to be less than or equal to 2. So it can be equal to 2. And the left side can be equal to the right side. It's either less than or equal to the right side. And in this case, it's equal. So it checks. Okay? It checks. All right, so again, we're going to have a quiz on Thursday on inequalities. And then next week we'll be having our exam on equations and inequalities, but we'll probably spend a couple days doing some review. Okay? We'll be spending a couple days doing some review, as well as going through the quizzes. Remember that you should always be checking Power School to see if you have any missing assignments, getting those handed in.